Our Earth, a vibrant world teeming with life, faces unprecedented challenges. For generations, human activities have reshaped landscapes and altered climates. We have relied heavily on resources that are finite, and our industries have often left a deep scar upon the natural world. The burning of fossil fuels, the clearing of ancient forests, and the relentless tide of pollution have pushed many ecosystems to their limits. The delicate balance that sustains life is under threat. Climate change, a direct consequence of these actions, now manifests in more extreme weather patterns, rising sea levels, and the loss of biodiversity. This is a critical moment in our planet's history, a time that calls for ingenuity and a profound shift in our approach to living. Yet, amidst these concerns, a beacon of hope emerges. This hope lies in human innovation, specifically in the realm of green technology. Green technology, sometimes called clean technology, represents a collection of scientific advancements and practical solutions designed to lessen our environmental impact. It seeks to work in harmony with nature rather than against it. The core aim is to conserve precious natural resources, to use energy more efficiently, and to promote systems that can be sustained for generations to come. This is not merely about fixing past mistakes. It is about forging a new path, a sustainable future where both humanity and the natural world can flourish together. It is a testament to our ability to adapt and to strive for a better world. The importance of green technology cannot be overstated in this current era. It stands as our most promising tool in the fight against environmental degradation. Imagine a world powered by the sun and the wind, where our homes and cities produce as much energy as they consume. Picture transportation systems that glide silently, emitting no harmful pollutants into the air we breathe. Envision industries that recycle all their waste, turning potential pollutants into valuable resources. This is the world that green technology strives to create. It offers a pathway to mitigate the damage caused by our past reliance on unsustainable practices and to build a resilient future for all inhabitants of this remarkable planet. The journey towards a greener future is a collective one. It involves scientists and engineers developing new solutions, policymakers creating supportive frameworks, businesses adopting sustainable practices, and individuals making conscious choices in their daily lives. The challenge is significant, but so too is the potential reward: a healthier planet, a more stable climate, and a legacy of stewardship for those who will follow us. Green technology is more than just a set of tools. It is a new philosophy, a way of thinking that places the well-being of our Earth at the very heart of human progress. It is an understanding that our prosperity is intrinsically linked to the health of the natural systems that support us all. The adoption of green technology brings with it a cascade of positive changes, touching almost every aspect of our lives and the environment. One of the most significant benefits is the substantial reduction of our carbon footprint. Traditional energy sources like coal and oil release vast quantities of carbon dioxide when burned, trapping heat in our atmosphere and driving climate change. Green technologies, particularly renewable energy sources such as solar and wind power, generate electricity with little to no greenhouse gas emissions. This shift is vital if we are to stabilize our climate and protect vulnerable ecosystems from the escalating impacts of global warming. Every solar panel installed, every wind turbine erected contributes to this crucial global effort. Beyond tackling climate change, green technology plays a pivotal role in the conservation of our planet's finite natural resources. For centuries, humanity has extracted resources as if they were limitless. Forests have been cleared, minerals mined, and water sources depleted at an alarming rate. Green technologies promote a more considered and sustainable use of these resources. For example, sustainable forestry practices, coupled with the use of recycled materials in construction and manufacturing, help to reduce the pressure on our forests. Similarly, innovations in water conservation ensure that this precious liquid is used more efficiently, safeguarding supplies for both human needs and the intricate web of life that depends on it. This careful stewardship is essential for long-term survival. The positive impacts of green technology extend directly to human health and well-being. Air and water pollution, largely byproducts of industrial activity and fossil fuel combustion, contribute to a wide range of health problems globally. By transitioning to cleaner energy sources and adopting greener industrial processes, we can significantly improve the quality of the air we breathe and the water we drink. Electric vehicles, for instance, eliminate tailpipe emissions, leading to cleaner air in our bustling cities. Sustainable agriculture reduces the use of harmful pesticides and chemicals, resulting in healthier food and less contamination of our soils and waterways. A healthier environment undoubtedly leads to healthier populations. Furthermore, the embrace of green technology stimulates economic growth and creates new opportunities. The transition to a green economy is fostering innovation and driving investment in new sectors, such as renewable energy generation, energy efficiency solutions, sustainable transportation, and advanced recycling. This shift creates a diverse range of skilled jobs, from engineers and scientists developing new technologies to technicians installing and maintaining green infrastructure. By reducing reliance on volatile global fossil fuel markets, nations can also enhance their energy independence and security. Green technology is not just an environmental imperative, it is an engine for economic resilience and prosperity in the 21st century. At the forefront of the green technology revolution is the remarkable advancement in renewable energy. The sun, our nearest star, bathes our planet in an immense and constant supply of energy. Solar technology has made incredible strides in capturing this energy. Photovoltaic cells, the heart of solar panels, are becoming more efficient and more affordable each year. We see them now not just on rooftops of homes, but also in vast solar farms stretching across sun-drenched landscapes. Innovative applications are emerging too, such as solar windows that generate electricity while remaining transparent, and even solar paint that could turn entire buildings into power generators. This silent, clean energy source holds immense potential to power our world sustainably. The wind, another powerful natural force, is also being harnessed with increasing sophistication. Modern wind turbines, with their gracefully rotating blades, are a common sight in many regions, transforming wind's kinetic energy into clean electricity. Engineers have developed larger and more efficient turbine designs, capable of capturing more energy even from gentler breezes. Offshore wind farms, situated in coastal waters where winds are often stronger and more consistent, are becoming a significant contributor to renewable energy portfolios. Furthermore, technologies like vertical axis wind turbines are being designed for urban environments, and artificial intelligence is used to optimize turbine performance by predicting wind patterns and scheduling maintenance. This ensures we get the most from this abundant resource. Beyond the sun and wind, water also offers significant opportunities for renewable energy generation. Hydroelectric power using the force of flowing water in rivers has been a reliable source for decades. Now, innovations are focusing on smaller-scale hydroelectric systems that have less environmental impact than large dams. Even more exciting is the burgeoning field of tidal and wave energy. The predictable ebb and flow of ocean tides and the relentless power of ocean waves represent a vast, untapped energy reserve. Technologies are being developed to capture this marine energy, particularly in coastal regions, offering another pathway to diversify our clean energy sources and reduce our dependence on polluting fossil fuels. The collective impact of these renewable energy technologies is transformative. They offer a clear route away from the finite and polluting fossil fuels that have powered our societies for so long, but at a significant environmental cost. By embracing renewables, we can drastically cut greenhouse gas emissions, combat climate change, improve air quality, and enhance our energy security. The transition requires investment and commitment, but the benefits of a world powered by clean, inexhaustible natural forces are undeniable. Nature itself provides the solutions, and human ingenuity is learning how to unlock them for a sustainable future, ensuring energy for generations without harming the planet we all share. The places where we live and work have a significant impact on the environment, from the materials used in their construction to the energy they consume throughout their lifespan. Green building technologies are revolutionizing the construction industry, aiming to create structures that are not only comfortable and functional, but also environmentally responsible. A key aspect of this is the use of sustainable materials. Instead of relying solely on conventional, energy-intensive materials, builders are increasingly turning to alternatives like bamboo, which grows rapidly and is incredibly strong. Recycled steel, reclaimed wood, and even innovative materials like self-healing concrete and carbon-negative bricks are reducing the environmental footprint of new constructions. Energy efficiency is another cornerstone of green building design. Modern buildings can be designed to work with the local climate rather than against it. Passive solar design, for example, utilizes the orientation of a building and the placement of windows to maximize natural light and heat from the sun in winter, while shading strategies minimize heat gain in summer. Green roofs covered with vegetation provide excellent insulation, reduce stormwater runoff, and can even create habitats for wildlife in urban areas. Smart building technologies incorporating sensors and automation can precisely control lighting, heating, and cooling systems, ensuring energy is used only when and where it is needed, drastically reducing waste. The ultimate goal in sustainable construction is the creation of net zero buildings. These remarkable structures are designed and equipped to generate as much energy as they consume over the course of a year. This is often achieved through a combination of exceptional energy efficiency measures and on-site renewable energy generation, such as building integrated photovoltaics, BIPV. BIPV systems seamlessly incorporate solar cells into building materials like roofing tiles, facades, or windows. Coupled with advanced energy storage solutions, such as batteries, these buildings can store surplus energy generated during sunny periods for use at night or on cloudy days, achieving true energy independence and a minimal environmental impact. These innovations in green building are not just about individual structures, they contribute to creating more sustainable communities and cities. By reducing energy demand, conserving water, minimizing waste, and using materials with lower embodied carbon, green buildings play a crucial role in mitigating climate change and protecting natural resources. They also create healthier indoor environments for occupants with better air quality and more natural light. As these technologies become more widespread and affordable, they offer a tangible way to build a future where our built environment exists in greater harmony with the natural world, ensuring shelter and comfort without compromising the planet's health. Section 5. The journey to clean mobility, transforming transportation. Our methods of moving people and goods have long been reliant on fossil fuels, contributing significantly to air pollution and greenhouse gas emissions. However, a quiet revolution is underway in the transport sector, driven by green technology. Electric vehicles, or EVs, are at the vanguard of this change. Powered by rechargeable batteries, EVs produce no tailpipe emissions, leading to cleaner air in our cities and reducing our carbon footprint. Battery technology is continually improving, offering longer driving ranges and faster charging times. The expansion of fast-charging infrastructure is also making EVs a more practical and convenient option for a growing number of drivers around the world. This shift from gasoline and diesel is a monumental step. While electric vehicles are becoming increasingly common, another promising green technology for transport is the hydrogen fuel cell. Hydrogen fuel cell vehicles, or FCVs, also produce zero harmful emissions, with water vapor being their only byproduct. They offer advantages such as longer ranges and quicker refueling times compared to many current battery electric vehicles, making them particularly suitable for heavy-duty transport like trucks and buses. The key to their environmental benefit lies in green hydrogen, which is produced using renewable energy to split water into hydrogen and oxygen. As green hydrogen production scales up, FCVs could play a vital role in decarbonizing sectors of transport that are harder to electrify. Innovations are not limited to personal vehicles. Public transportation is also undergoing a green transformation. Cities worldwide are investing in electric buses which operate quietly and without emissions, improving the urban environment for everyone. High-speed electric trains offer an efficient and lower carbon alternative to short-haul flights and long-distance car travel. Furthermore, shared mobility solutions such as bike sharing and e-scooter programs are being enhanced with smart technology, encouraging more people to choose active and sustainable transport options for shorter journeys. These collective efforts aim to reduce traffic congestion, improve air quality, and make our urban spaces more livable and pleasant. The transition to sustainable transportation is essential for building a healthier and more sustainable future. By embracing electric vehicles, exploring the potential of hydrogen fuel cells, and investing in green public transport, we can significantly reduce our reliance on fossil fuels and mitigate the environmental impact of our mobility. This journey requires continued innovation, supportive government policies, and a willingness from society to adopt new ways of moving. The reward is cleaner air, quieter streets, and a transportation system that supports both human needs and the well-being of our planet, ensuring we can travel without costing the Earth. Section 6, From Waste to Wonder: Revolutionizing Resource Management. The concept of waste is being fundamentally rethought thanks to green technology. For too long, humanity has operated on a linear take-make-dispose model, leading to overflowing landfills and the depletion of valuable resources. The circular economy offers a transformative alternative. This model emphasizes keeping resources in use for as long as possible, extracting maximum value from them whilst in use, then recovering and regenerating products and materials at the end of their service life. Advanced sorting systems, often driven by artificial intelligence, are improving the efficiency of recycling plants, making it easier to separate and process different materials. The development of innovative, biodegradable plastics also promises to reduce the scourge of persistent plastic pollution. Beyond recycling and reuse, green technology is also finding ingenious ways to convert what was once considered waste into valuable energy. Waste-to-energy technologies are playing an increasingly important role in sustainable waste management. Processes like anaerobic digestion use microorganisms to break down organic waste, such as food scraps and agricultural residues, producing biogas that can be used to generate electricity or heat. Other advanced methods like plasma gasification and pyrolysis can convert municipal solid waste into syngas, a fuel gas mixture, or bio-oil, further reducing the volume of waste sent to landfills and recovering energy in the process. These technologies help close the loop, turning a problem into a resource. A significant challenge in waste management has been the proliferation of single-use packaging, particularly plastics, which can persist in the environment for centuries. Green innovation is tackling this issue head-on with the development of biodegradable and sustainable packaging alternatives. Materials derived from plants, such as cornstarch or mushrooms, are being used to create compostable packaging that breaks down naturally after use. Some companies are even experimenting with edible packaging, further minimizing waste. These innovations are crucial in reducing our reliance on fossil fuel-based plastics and mitigating their impact on our oceans and ecosystems. The goal is to make packaging protective for products but harmless to the planet. By embracing these advanced waste management and recycling technologies, we can significantly reduce our environmental footprint. The shift towards a circular economy, coupled with effective waste-to-energy solutions and sustainable packaging, minimizes landfill use, conserves natural resources, and reduces pollution. This transformation requires a concerted effort from industries, governments, and consumers. It means designing products for durability and recyclability, investing in modern waste processing infrastructure, and making conscious choices to reduce, reuse, and recycle. In doing so, we can transform our relationship with waste, viewing it not as an endpoint but as a valuable resource for a sustainable future. Section 7. Nourishing the Future: Green Innovations in Agriculture. Traditional agriculture, while essential for feeding our global population, has often exerted considerable pressure on the environment. It can lead to deforestation, soil degradation, significant water consumption, and pollution from pesticides and fertilizers. Green technology is now ushering in a new era of sustainable agriculture, aiming to produce more food with fewer resources and a lighter environmental touch. Vertical farming is one such innovation, where crops are grown in stacked layers indoors, often in urban environments. This method uses significantly less water and land than conventional farming, and by controlling the environment can eliminate the need for pesticides, producing fresh food closer to consumers. Hydroponics and aeroponics are closely related techniques that further optimize resource use in food production. In hydroponic systems, plants are grown with their roots submerged in nutrient-rich water without any soil. Aeroponics takes this a step further, growing plants with their roots suspended in the air and misted with nutrient solutions. Both methods allow for precise control over nutrient delivery, dramatically reducing water usage compared to traditional soil-based agriculture. These soil-less farming techniques can be implemented in diverse locations, including arid regions or areas with poor soil quality, enhancing food security and reducing the transportation footprint associated with our food supply. Precision agriculture represents another significant leap forward, leveraging modern technology to make farming more efficient and sustainable. This approach uses tools like GPS, satellite imagery, drones, sensors, and artificial intelligence to monitor crop health, soil conditions, and weather patterns with remarkable accuracy. Farmers can then make highly informed decisions about when and where to apply water, fertilizers, and pesticides, using only what is necessary. This targeted approach not only increases crop yields and quality, but also minimizes runoff of excess chemicals into waterways, reduces water waste, and lowers overall operational costs, making farming both more profitable and more eco-friendly. The environmental impact of traditional livestock farming, a major source of methane emissions and deforestation, is also being addressed through green innovations. Lab-grown meat, also known as cultured or cellular meat, involves cultivating meat directly from animal cells in a controlled environment without the need to raise and slaughter animals. This technology has the potential to drastically reduce land use, water consumption, and greenhouse gas emissions associated with meat production. Alongside this, the development and growing popularity of sophisticated plant-based meat alternatives are providing consumers with more sustainable protein choices. These advancements in food technology are vital for feeding a growing global population while protecting our planet's precious ecosystems. Section 8. Guarding our precious water, technologies for conservation. Water is the essence of life, yet fresh, clean water is a finite and increasingly stressed resource in many parts of our world. Climate change is exacerbating water scarcity through altered rainfall patterns and prolonged droughts. Green technology offers crucial solutions for conserving and purifying water, ensuring its availability for both human populations and the natural ecosystems that depend on it. Desalination, the process of removing salt from seawater to make it drinkable, has become more efficient and less energy-intensive thanks to advancements in membrane technology like reverse osmosis. Alongside this, innovative wastewater recycling systems are treating used water to a high standard, making it safe for reuse in agriculture, industry, or even for replenishing groundwater. In agriculture, which accounts for the largest share of global freshwater consumption, smart irrigation systems are making a profound difference. Traditional irrigation methods often lead to significant water loss through evaporation or runoff. Smart systems, however, use sensors to monitor soil moisture levels, weather conditions, and plant needs in real time. This data is then used to automatically adjust the amount and timing of water delivery, ensuring that crops receive precisely what they need, when they need it, without wastage. Techniques like drip irrigation, which deliver water directly to the plant roots, are also becoming more widespread, further enhancing water use efficiency in farming. Protecting our existing water sources from pollution is as important as finding new ones. Green technologies are being developed for more effective water purification and pollution control. Advanced filtration systems can remove a wider range of contaminants, including microplastics and emerging pollutants. Natural solutions, such as constructed wetlands, are also being used to filter and clean water in an eco-friendly way. Furthermore, technologies that monitor water quality in real time can provide early warnings of contamination events, allowing for swift action to protect public health and aquatic environments. Every drop saved and every water source protected contributes to a more water-secure future. The careful management and conservation of water are fundamental to building a sustainable future. By investing in and implementing these green water technologies, from advanced desalination and recycling to smart irrigation and robust purification methods, we can address the growing challenges of water scarcity and pollution. These innovations not only help to secure water supplies for human needs, but also reduce the strain on our planet's vital freshwater ecosystems such as rivers and lakes. Ensuring that everyone has access to clean water while preserving the health of our aquatic environments is a critical component of global sustainability efforts, and green technology is leading the way. Section 9. The Path Forward. Challenges and triumphs in green technology. Despite the immense promise and rapid advancements in green technology, the path to widespread adoption is not without its challenges. One significant hurdle is often the high initial investment cost associated with some green solutions. While many green technologies offer long-term savings and environmental benefits, the upfront expense for solar installations, electric vehicles, or retrofitting buildings for energy efficiency can be a barrier for individuals, businesses, and even nations. Overcoming this requires innovative financing models, government incentives, and continued research to bring down costs and make these vital technologies accessible to all segments of society, ensuring an equitable transition. Another challenge lies in public awareness and education. Many people may not be fully aware of the range of green technologies available or the profound impact their choices can have on the environment. Misinformation or a lack of understanding about the benefits and practicality of these solutions can slow down their adoption. Consistent and clear communication, educational programs, and showcasing successful examples of green technology implementation are crucial for building public support and encouraging behavioral change. Furthermore, inconsistent regulatory policies and a lack of robust long-term incentives from governments can create uncertainty and hinder investment in the green sector, slowing the necessary pace of transition. Technological limitations also persist in certain areas, requiring further research and development. For instance, while renewable energy generation has made remarkable strides, energy storage remains a key challenge. Developing more efficient, affordable, and sustainable battery technologies or other storage solutions like green hydrogen is critical for ensuring a reliable supply of clean energy, especially when the sun isn't shining or the wind isn't blowing. Similarly, scaling up technologies like carbon capture and storage to effectively help industries achieve net zero emissions requires ongoing innovation and substantial investment to prove their viability and environmental integrity on a large scale. Yet the future of green technology is incredibly bright and filled with immense potential. We are witnessing an acceleration in innovation. Advancements in energy storage, including improved batteries and supercapacitors, are on the horizon. Artificial intelligence and smart systems will play an increasingly vital role in optimizing energy consumption, managing waste more effectively, and making resource use more efficient across all sectors. The widespread adoption of green hydrogen for energy storage, industrial processes, and transportation is poised to become a reality. As these technologies mature and become more integrated into our daily lives, they will pave the way for a truly sustainable future where human progress and environmental health go hand in hand, ensuring a thriving planet for generations to come.